Welcome. Thank you for joining me for our first flipped classroom notes. Now, before we get started, I would like to first address what is good note-taking skills, okay? Now, before you start these videos, something you should keep in mind is you should always have your packet in front of you and something to write with. Something else that is always a good idea, because as this class continues, we will be doing calculations. I don't want you sitting there just taking my word for it. I want you to know that you know how to use your calculator as well. So it is also a very good idea to have that sitting in front of you. All right, so today we're talking about lesson 1.2, properties of real numbers. Objectives I want us to get out of today: how to graph and order real numbers, and how to identify properties of real numbers. Now, throughout this class, you'll be asked to identify the types of numbers that make sense in a given situation. So, for example, if I were to ask you to the nearest hour, how many hours of sleep did you get last night? Now, think about how nonsensical it would be if you tried to give me a negative answer, okay? Negative values would not be involved in that domain of numbers, okay? That solution of possible numbers. So what we're going to talk about is what are these different classifications of numbers? I'm hoping this is review for you, but it never hurts to go over again. So, natural numbers. The natural numbers are really just what you can count in the real world. So we're talking about 1, 2, 3, 4, so on and so forth. Anything you can physically count in the real world. Now, whole numbers. Whole numbers are essentially the same thing, okay? Now, the only difference is whole numbers also encompass 0, okay? That is when the idea of nothing came into play. But then the rest of your list is simply the natural numbers. Now, integers start getting interesting because this is where negative values started coming in. So you could have numbers like -2, -1, 0, and all the positive numbers still. Okay, but this time it goes on in both directions forever. Rational numbers. Rational numbers, this gets even more interesting. So a rational number is defined as a number that can be written as the quotient of 2 integers. Okay, now that can be a little confusing, so let me break it down for you. There's 4 types of numbers we can include in rational numbers. Any whole number is a rational number. Why? Well, because it can be written as a fraction of 2 integers. I could write that as 4 divided by 1. Now, the next is obviously any fraction. 1/2, quotient of 2 integers. Now, there's also some other numbers that work. Think about a number like 0.75. Why is that rational? Well, because it can be written as 3/4. And then finally, something that looks like this, 0.3 repeating. 0.3 repeating, we know it's the same as 1/3. So by the same rationale, we are talking about a rational number, okay? So when it comes to rational numbers, we're talking about integers, fractions, terminating decimals, so decimals that have an end, or decimals that repeat at their end. And you'll see that bar over it. And then finally, irrational numbers. Well, anything that is not rational by definition is irrational. So we get a lot of zany numbers here. This is where we talk about numbers like pi. Things like the square root of 2. Those are the most common ones. Many square roots, pi, but then there are some other things that can count too. Logarithms of numbers, such as that. We're not going to dive too much into that yet, but do realize there are many things that can cause a number to be irrational, okay? But again, the most common ones I want you to recognize, pi, and then the square root of most numbers. All right, so if we are talking about which set best describes the amount of sleep you got last night to the nearest hour, the question I started class off with. Well, if we're going to the nearest hour, we're going to be talking about 1, 2, 3, 4. Now, hopefully you got some sleep. Hopefully 0 is not an answer here. But In all reality, pull an all-nighter, you could get 0 hours of sleep. So if we're talking about 0, 1, 2, 3, that means we are talking about the whole numbers. Okay? So that is how you respond to that question that I opened class with. Now, the next example, the opposite reciprocal of an integer is what type of number? Now, when we're talking about the opposite reciprocal of an integer, well, first we have to realize what we mean by an integer. So I'm going to use the number 2, for example. That's going to be the integer we start with. Opposite reciprocal. So if you recall what that means, to make the opposite reciprocal, it means I'm making it negative, and I'm putting that number on the bottom of the fraction. Okay, I'm turning it into a fraction essentially. Opposite reciprocal. So now, if we're looking at something like -1/2, let's think about that. Well, now we're talking about fractions. So the only place that I'm seeing fractions are the rational numbers. So when we take the opposite reciprocal, we're talking about a rational number. So I would recommend to have this handy. Okay, this chart will really help you because I realize it can be difficult remembering the exact specifications of each category. But if you have this list, it'll make it much, much easier for you to remember. So, page 2. So our next example, graph the two numbers on a number line and compare them with inequality symbols. Now, in order to graph those, these are not nice numbers, if you've noticed. So, what I'm going to have us do, the best way to recognize these numbers is turning them into a decimal form, okay? So I'm going to whip out my calculator, and I'm going to calculate what is the square root of 8. And I'm getting about 2.83. And again, that's one of those irrational numbers, so I'm never going to be able to write the whole thing. That's just a best approximation for it. 11/4, a fraction of 2 integers. So this one is a rational number. So when I calculate that, I can actually tell you it is exactly 2.75. And now notice how much easier it is to compare those two numbers. So when I'm making my number line, maybe I'm going to start with 2.5, 2.6, 2.7, 2.8, 2.9. So I'm making my number line. Square root of 8 is 2.83. So that's going to be about here. All right, 2.75 is going to be exactly halfway between 2.7 and 2.8. So I'm going to put that right there. And now to compare those two numbers, it wants us to compare them with an inequality symbol. So I'm comparing square root of 8 and 11/4. Well, I'm sure you guys remember the inequality sign opens towards the larger number. So what that means is it's going to open towards the square root of 8 because that is the larger number. So this would be completely answering the question, putting it on the graph and showing me the inequality symbol. That's another thing to make sure you pay careful attention to in this class. If there's multiple pieces to a question, please make sure you respond to each piece, okay? This one took 2 responses in order to answer it completely. Now, when we are talking about properties of real numbers, there are some true properties, not just categorizing them, but true properties. Now, these properties only work for addition and multiplication, okay? Now, again, some of these are more important than others. I'm going to touch on all of them, but then I'm going to emphasize a couple of them for you. The closure property, probably something you really haven't heard before, okay? It's something you probably know, just you've never heard a name for it. What the closure property means is if A, B, and C represent all real numbers, that means A plus B is a real number. Okay? Closure, all it means is that the solution is also in the original set of values, okay? So if A and B are both real, A plus B also must be real. Same thing applies for multiplication. If A and B are both real numbers, AB is also a real number. Commutative. Now this is where it starts getting tricky, okay? Commutative is talking about order. So what that means, the order does not matter. A plus B is exactly the same as B plus A. So for example, 1 plus 2 is 3. Exactly the same thing as 2 plus 1, also 3. And the same thing applies for multiplication. A times B equals B times A. So 1 times 2 is 2, 2 times 1 is 2. They equal the same thing. Now, it's really easy to confuse commutative and associative. What associative says is grouping doesn't matter. So A plus B plus C is the same thing as A plus B plus C. Okay, how I group them does not matter. Same thing for multiplication. A times B then times C is the same thing as A times multiplying B times C. The way that I like to remember this, a little trick that I have, associative, sounds like association. Association is another word for a neighborhood, so a group of people. So associative means grouping doesn't matter, okay? Because again, these two are the most common to confuse, but if you remember, associative makes you think of association, which is like a neighborhood, group of people. That's how you can remember that that is one that deals with grouping of numbers. Okay? So, identity. The identity is what doesn't impact that operation. So, for addition, the identity is 0. Because adding 0 doesn't impact the solution whatsoever. So, for multiplication, the identity is something different. The identity is multiplying by 1. Because when we multiply by 1, you guys will know, it does not impact your solution whatsoever. Whatever you multiplied is going to stay the same. Inverse. Inverse operations. Basically asking, well, what is the opposite? What can I do to undo that property? So, addition. The inverse is subtraction. Undoes it. For multiplication, the inverse is going to be division. And those I have full confidence you guys know, okay? Finally, distributive. This one doesn't really go into a nice little category of addition or multiplication because it kind of spreads over both. So when it comes to distributive, I'm hoping you remember, you're looking at something like this, okay? You have two things being added in parentheses, and there's something multiplying it on the outside. And what the distributive property says, that's the same thing as multiplying that A through. So A times B plus A times C. Which again, I know you guys have seen this for years, okay? You are probably rock stars at it, but it never hurts to have a little refresher. So before we end this video, I quickly want to go over 2 examples with you, okay? So identify the properties shown. 2 plus 5 plus 4 and 5 plus 4 plus 2. So what I want you to notice, the order of the things that they gave us is different. The first part we're starting with 2. Second part we're ending with adding the 2. They've switched the order, okay? So look up at our little note sheet there. Notice commutative. The commutative is the one that says if you flip the order, it does not matter, okay? For addition and multiplication, I should specify. And a final example, identify the property shown. So here, notice, in the first one, we're multiplying A times C, and then multiplying by 2. In the next one, we're multiplying 2 and A, and then multiplying C at the end. So the order of everything is exactly the same. This time, the way that we group them is different. So remember, grouping. I hope that you remember association, which is the associative property. Okay? Again, I'm hoping that little trick helps you. If you have your own little mnemonic device, go for it to help you remember it. Okay? Whatever it takes. So that is going to be the end of this first note video. Thank you for your time, and I will see you for our next video.